Hey, I'm going to do this in English, right?
Yeah.
Yeah, sorry about that. So welcome to this seminar tonight. So my name is Magnus Sahlgren. I am here to talk about natural language processing. And we're going to talk about natural language processing from the perspective of security applications. So I'm going to talk about how we can use natural language processing in security applications, and we're also going to touch upon how NLP might be used in adversarial. Also count that. And a lot of the things that I'll be talking about here is based on my experience in working in this general area. So I'll begin with a short background of who I am and what I have done. So I've done research in the general field of natural language processing for around 20 years by now. Started out at the Swedish Institute of Computer Science back in 2000. Did my PhD in computational linguistics at Stockholm University. So my background is actually in linguistics and philosophy, which is, I guess, quite an anomaly in the computer science field. A couple of years after that, we spun off a company called Gavagai and did the startup thing for a couple of years. That was fun, but I'm a researcher, so I went back to the Research Institute in 2016. Also helped to set up the data science team at the Swedish Defense Research Agency, and from last year onwards I'm focusing entirely on the NLP group at RISE, leading the research there. So a few words about RISE. So RISE stands for the Research Institutes of Sweden. It's a bigger organization. Basically, it's formed from collecting all the technical research institutes in Sweden under a common name. So Statens Provningsanstalt, Acreo, SIX, Verea, etc. under a common name. So we do research in basically all technical areas, including computer science and artificial intelligence. So fairly big place. We're around 3,000 employees at the moment, a fair amount of PhDs. And we have offices all over Sweden, so quite distributed. But I'm from the computer science division, which is the old Swedish Institute of Computer Science. And we do research broadly in computer science. That means everything from networking, data-intensive computing, human-computer interaction, and of course big data and artificial intelligence, and application areas like natural language processing. This picture basically says the same thing, but from a big data stack perspective. So basically we contribute to all parts of this big data stack. So all the way from networking to processing pipelines and all the way up to applications and algorithms. And natural language processing would be on the top there. So it's an application rather. So natural language processing, I'm pretty sure that most of you who are in this webinar have heard about natural language processing. So basically what we do is use computer systems to analyze, also to understand, and also to generate natural language. And we're going to look at applications of all these aspects of NLP tonight. So we are at RISE an applied research institute, so that means that we work with real problems and with real data. And I think that's an important point to make, because real data is often very messy and it's incomplete, and it puts other requirements on the types of technologies you can use to process that. Because if you only use data that's in the lab, it's typically neat and it's controlled and it has been verified. Real data is not at all like that. And especially in security applications that we will talk about, data can be really messy. So that also means you have to choose your algorithms to fit with the data. That's very important. But the research that we do in our group is mainly focused on language AI. So we're trying to build algorithms and systems that can learn and understand language as we humans learn and understand language. So that's called natural language understanding or representation learning. And we're going to see some examples of how you can use this type of technologies in security applications later on. Right, so NLP, more technically, how do you do that? So this is a picture that I would have showed you a couple of years ago if I would have explained how natural language processing works. So you have some text data and you want to analyze that in some way. So in the traditional natural language processing is a pipeline. So you go through a number of sequential processing steps, like tokenization, and that's simply just trying to figure out which units should we use to analyze the data. That might seem like a trivial problem, like why can't we just split text on white space and there we have like words. But of course not all languages use white space, and in some languages it's often not even clear how to segment sentences, like in Thai. So tokenization might seem trivial, but it's really not a non-trivial problem. And that goes for all of these boxes. And that also means that if you do an error in your processing pipeline, it will propagate all through your processing pipeline and produce errors in the analysis. But so you might do things like assigning part of speech tags to the words to disambiguate words grammatically, and you might do syntactic parsing and add information about which entities are names and places and times. And then once you have done all of these processing steps, you feed it into a machine learning process, and then you do the end application, which might be classification or sentiment analysis or translation or something else, right? But so this is typically not how we do it nowadays. So what we do now is much more like this. So we have a text, and then we don't do any pre-processing. We feed it directly into a deep learning model. And then we let the model itself figure out what it needs to learn to solve whatever problem we want it to solve, if it's sentiment analysis or translation. And we might not even do tokenization. We just might feed the raw character sequence into this model and let it figure out the tokenization by itself. This is also called end-to-end learning, and it's very powerful, and this is the way that we do natural language processing nowadays. Now, having said that, we're going to talk about security applications. And in security applications, you often use very simple and traditional methods. And then we have the question, why do we do that? And this is where I normally would expect some answers. But since we are online, I'm going to answer it myself directly. One important point is that, well, in many of these cases, we don't have any training data. So we can't use traditional machine learning here. And we're going to talk about some of these cases where we don't have training data. And where we don't have training data, we can't really use machine learning. So this is one reason why this is hard to use modern techniques. And another reason is that a lot of the work in this domain is driven by some sort of theory of the phenomena that we want to analyze. And we're going to see some examples soon of that, but just to forego my own presentation. So if we want to hunt terrorists, for example, on the internet, much of that work is driven by psychological theories of how terrorists act. And so we're trying to implement the theory rather than learning something from examples. But I think maybe the most important aspect here is interpretability or explainability. So if you make a decision that someone seems to be a terrorist based on the text content of this person's writings online, you are going to have to explain that decision. And if you have a black box deep learning system that just says that, well, this guy is a terrorist, that's not going to cut it, especially if it's a court case, right? You have to explain your decision. And that's much simpler to do if what you're doing is simply just a keyword analysis, because then you can point to the actual words, right? And I think we're going to come back to this point later on. But so a lot of the work is quite simplistic, and you're going to see that. But we're going to end with some very advanced techniques. So we're going to cover the entire spectrum, I hope. And these are the applications that I was going to talk about. So first of all, we're going to talk about hunting terrorists, extremism and radicalization, and also cover the concept of lone wolf factors. And then we're going to talk about open source intelligence and media monitoring applications. And then we're going to turn to how we can characterize authors. So what can we say about an author of a text? So author profiling and author identification. And then we're going to end with what is probably the most important aspect and the thing that we will see more in the future, which is information operations and techniques for and against that. Right. But we'll start with terrorism or extremism and radicalization. And as I said, a lot of this work is driven by theory, and there are several different types of theories about how these type of actors behave. And usually this is based on what's called warning behaviors. And that's defined by domain experts and psychologists. I think one of the most commonly used one is called TRAP 18, which stands for Terrorist Radicalization Assessment Protocol. And so what you try to do is define warning behaviors that these type of actors display. And we can take some examples. So a lone wolf actor is basically a terrorist without an organization. So it's driven by some internal cause. And one of the warning behaviors that people talk about here is fixation. That is fixation with some topic or with some ideology or with some person. And there are several examples of this, of course. I think we don't have to mention anyone by name, but a lot of the lone wolf actors that has been in our area of the world has been driven by fixation with ideological factors, for example. Another common behavior with lone wolf actors is that they tend to leak their intent of committing the violent act. So you see that in school shooters and in these lone wolves that have been active here in the region. They typically publish some manifesto or they communicate with their peers in communication channels and say that basically I'm going to do this now. So there might be opportunities to capture that type of content online. Another example is radicalization. So that's basically the process before someone becomes a terrorist. So the act of becoming radicalized. So one of the warning behaviors that people talk about is called dichotomous thinking. So an increasing dichotomizing of the world in us and them, right? An in-group and an out-group. And so if we have all these warning behaviors, so what do? Well, people try to define linguistic markers that manifest these behaviors. And that sounds really sophisticated, but it's not. It's just simple keywords, right? So in the case of fixation, we might have a list of common ideologies that people tend to fixate on. Or in the case of leakage, we might have verbal expressions like I'm going to, etc. Or in the case of dichotomous thinking, it might be as simple as high occurrence of personal pronouns like us and them, which increase over time. So that's a fairly simplistic analysis. And what you do, once you have defined your set of keywords that represent one of these warning behaviors, is you simply count occurrences of these keywords. So if we analyze some open information on the internet, we would simply count occurrences of these keywords over time, and we might see some interesting patterns evolve. So very, very simplistic. It's also surprisingly powerful in some cases. And we have a question.
Yes. So you say like gathering information, this kind of metadata from online sources. What about GDPR? Is it problematic to do this kind of harvesting of traits?
Oh God, yes. It is extremely problematic. So if you're a researcher like me, you have to think about GDPR all the time. And if you want to do research in this area, you need to have ethical consent and ethical plans and stuff like that. And you need to have GDPR plans, and it's problematic to do research in this area. But we're now talking about more operational environments where a security service might listen to something, and GDPR I don't think applies to that. So yes and no, depending on who you are, yes. Okay, but so keywords, and I hope that everyone who listens to this now sits there and wonders, why do people use such simple techniques? It's too basic, right? And yes, it is. And the obvious problem is vocabulary variation. Because if all of us would try to come up with some keywords to describe, for example, this presentation, you would all come up with different keywords, right? And that's also called synonymy. Several different words can be used to refer to the same thing, right? So how do you ensure that your linguistic markers cover all the necessary keywords? It's a difficult problem. One potential solution is to use AI or natural language processing techniques to try to expand on the keywords. And we use something called embeddings for this. So embeddings is a good example of language AI, and it's a type of technique that learns how words are used in data. And all of these techniques are based on something called a distributional hypothesis, which basically states that if we have a couple of words that tend to occur in the same type of context, then these words are typically related semantically. And if we use that type of statistics to build a topological structure of a vocabulary, we will end up with something like what you see in the picture, basically a map over the vocabulary. So the point of this is that words that mean similar things are close to each other, and words that have very different meanings are far away from each other. And so you can use this type of technique to expand your keyword lists. Something that I think is particularly interesting with these type of techniques is that there have been studies that show that we have a very similar structure in our wetware, in our brain. So word knowledge in the human brain seems to display a very similar topological structure. And that's quite interesting from an AI perspective, that we can actually learn this by simply just letting a computer system read lots and lots of text. So that's cool for a researcher like me, but it's also practically useful because you can actually build these models quite efficiently. And I think many of you have heard of a framework called Word2Vec, which is a very simple neural network model that learns these type of embeddings from text. It's very, very efficient and can be used for very large-scale data, but it's not a new idea. So I think Word2Vec was published in 2013, and it became very popular. It's basically the same idea as in Jeff Elman's simple recurrent networks from 1990. So basically we try to build a language model that predicts the next word in a sequence, and by doing that we will learn a useful hidden layer basically for all the words. And there are many other approaches to building embeddings. One very simple one is to build a matrix of co-occurrence counts and then simply just factorize it with your favorite factorization algorithm. And that will also give you very useful embeddings. But so the way that we would use this type of representation is to do term set expansion. So we let a domain expert come up with some keywords for some warning behavior, and then we would let an embedding model try to expand on those keywords. So in this example that you see, we have a word like counterintelligence, and then we can ask an embedding model, what other words do we have that are similar in some sense? And then we get a lot of other words, and then we have to pick and choose which ones are the best for our particular information need. And you can also build an active learning system based on this type of representation, so you can train the system to select which words are the most appropriate to use for your need. But so this is quite an interesting technique. It works also in basically all languages. So if you have an acronym like KGB and you have different embeddings for different types of languages, you will have similar terms related to the concept of KGB in all of these languages. And we have a question.
Yes, Mumin asks, can you find terrorists by what words they use in relation to each other, even when they are not talking about terrorism?
So I'm an expert on natural language processing and not on terrorism. So I would say, given a warning behavior and given sufficient amounts of data from someone that is a suspect, we will probably be able to identify warning behaviors if they are present or not over time. Then the other question is, well, is that sufficient then to call someone a terrorist or not? I'm not even going to go there. That's someone else can answer that question. But if it's manifested in language use, then we can probably measure it. I would leave it at that.
Yeah, and I think you mentioned earlier, like if you use a lot of terms like they and us and we and them and so on, it might give hints, I guess.
Yeah, well, so I mean, if you would only look at one linguistic marker, like occurrence of us and them, you would capture all politicians, right? But so that's not sufficient. And in fact, we did a small demonstration of a system that would collect web data, and this was before GDPR. Collect web data, implement some warning behaviors, and rank posts with regards to that. And it's quite, if you do that, and that's a nice, you can do it yourself, right? If you do that, you will see that you don't really capture terrorists doing that. So what you need is really, really specific warning behaviors, and you need to look at the temporal progress over time. And also, I think you need to involve social network analysis and other metadata factors there. Yes. Something that is particularly astonishing, I think, with these type of techniques is that, so what you see here is that you can actually find related concepts, but you also see that you have actually found multi-word units here. And this is actually an example of a system that learns the units simultaneously as it's learning the semantic relations. And I think that's quite astonishing that you can do that by just exploiting simple statistics in language. Anyway, these type of techniques are also quite useful in multilingual scenarios. So you might have a list of warning behaviors in English, and there are such lists, but then you might want to do analysis on Swedish or some other more exotic language, Amharic or something. Then you can actually exploit this type of technique to transfer the warning behavior lists. So it's like a multilingual dictionary in a sense, and that's also quite cool, I think. Okay, so what can you do with this? Here's an example of what you can do with this type of analysis. This is something, small analysis that I did during my time at the Swedish Defense Research Agency. These are a number of themes that have been identified and expressed by domain experts. And then what we did was to use an embedding model to expand on the keyword lists to ensure that we had good recall. And then we analyzed the official ISIS propaganda magazines. And this might be something not everyone knows about. There is actually an official ISIS propaganda magazine, and it's a glossy publication with a layout and colorful images and stuff like that. It's quite weird. And you see over time how these themes evolved in the propaganda. The dotted line in the middle here is when the propaganda magazine changed its name from Dabek to Ramaya, and that also coincides when the propaganda became more violent. And what we can see is, for example, the theme relating to vehicles, like cars and trucks and stuff. becomes much more prevalent in the later propaganda. And that also coincides or actually precedes the terrorist attacks that we saw in Europe using vehicles. So you could actually, I wouldn't say predict it, but you could actually see that trend in the propaganda before it actually happened. So as an example of what you can do using very simplistic techniques. So another thing you can do using keywords and embeddings is to use these representations to form a structured representation of knowledge. So basically building a knowledge graph. So connecting different concepts to each other based on their meaning and their use. I'm guessing people are familiar with social network analysis, where you have people who are connected by some relation. This would be similar, but we don't have people, we have concepts instead. And relations can also be syntactic relations or semantic relations. And that's quite a powerful type of knowledge representation that we can use for reasoning or for simply exploring the representation space. And I think that we are going to see much more of knowledge graphs in the near future. This is a very hot topic in the research community at the moment. Okay, so that's about terrorism and radicalization. Now we're going to talk about open source intelligence and social media monitoring, or actually we should maybe not only call it social media monitoring, but media monitoring. And so the idea is to analyze open sources and extract information from that. And when we talk about OSINT or media monitoring, we are often talking about open sources on the internet, just collecting web data and analyzing that. And the typical questions that people want to answer when they do this is, so what are people talking about out there? So if you analyze some specific web forum, for example, so what are they talking about here on the web forum? What topics are they talking about? And how are they talking about these topics? How do they feel about it? Do they seem angry, or are they happy, or what is happening there? So this is a nice complementary tool to use in intelligence work, because as an analyst, intelligence analyst, you will get access to much more information than in your typical intelligence channels, and you will also get access to different information that you would typically get in intelligence channels. And then, of course, I mean, the challenge is to how do you find what is actually useful in all of this data. So what can we do with this? We collect a lot of data and then we want to figure out what. This picture is from a movie that maybe some of you have seen. I'm going to ask, have you seen this movie? Or, you don't recognize this. This is from a movie called Limitless. So the character there in the middle, he takes a pill, I think, and the pill has the effect that he can read basically the entire internet and remember everything. So what does he do with all this information? Well, he trades on the stock market. This is apparently what people do. And there, I'm going to take a tangent here, but just for a little bit. This is something that is quite common for media monitoring. So this is basically the first thing people think about when they start collecting web data and think about what can we do? Well, we can probably trade on the stock market. So I guess you recognize at least one of these characters here. The actress is called Anne Hathaway, and the gentleman is called Warren Buffett. So what do they have in common? Well, the name Hathaway, actually, because Warren Buffett's company is called Berkshire Hathaway. And it seems that there has been some analysis that show that the stock price for the company Berkshire Hathaway increases every time where the actor Anne Hathaway has done a public appearance and won an Oscar or have a movie premiere. And I have no idea if there is a an automated trading machine here that collects positive news about Hathaway and trades on that. But there seems to be a correlation, and that has been published about, so that's a verified thing. Anyway, I'm drifting. You can do some interesting and useful analysis also based on open source information. This is an example from a couple of Finnish researchers where they used open information to predict bank stress in the European bank system using deep learning techniques. And they have some very nice results that show that you can actually do that. So it is quite a useful approach. But so what do people use OSINT for in security? Well, one thing is to try to detect hate speech. So hate speech is basically threats and hate online. And the way that people do that is often using very simplistic techniques like word lists. And I'm just going to show you an example here of what it can look like when you use actually just simple techniques. So here we have the Swedish ministers and a couple of hate speech categories like anger and general threat or just being rude to someone, etc. And the first graph that you see is simply just the frequency of such words for the different ministers. So what you see is that Stefan Löfven, our prime minister, he gets the most hate speech, which is perhaps not very surprising because he's the one who also gets most talked about in the media, right? So if you normalize based on frequency, you see another picture. So now you see that Mikael Damberg actually gets the proportionally most hate speech. But if you now start to count instead deviations from the expected counts, you see that basically only the, what's here called the naughtiness for Stefan Löfven, that is people being rude, that's the only interesting signal in all of this data. So my point here is that it depends on how you look at your analysis, what type of conclusions you will draw. So it's not only about how you measure, it's also about how you interpret what you measure. So that's an important point. Right, so a couple of more examples about media monitoring, and we're still only talking about very simplistic methods, but these are examples of, well, maybe surprisingly when these simplistic methods actually work and actually can be used for something. This is quite an old analysis that we did, mentions of Sweden in Russian online media. And there are a couple of different categories here. We have fear, we have positivity, we have skepticism, and we have violent mentions. And you can see some interesting patterns here. For example, there is a spike in skepticism at the beginning of 2016, and that seems to be some sort of fake news, some basically made up article of the political system in Sweden. And then you also see a huge spike in violent mentions about Sweden. And if I don't remember incorrectly, I think this was a very small piece of news. I think it was like a fight at a pizzeria somewhere very remote in Sweden. It was a news item that never made it into Swedish press, but that was really propagated in Russia as an example of how violent it is in Sweden, right? So, yeah, maybe you can say that what we're seeing is an information operation here, naturally. And then we see a small spike in positivity, and that's related to the Eurovision Song Contest, which I think this year was held in Sweden. So you can see these effects. I'm going to take a couple of more examples of this, which I think is quite cool. So this is respiratory infection in Sweden, the blue line that you see, and the other line is influenza, basically. And this is old, so this is not It's based on data from a European project called InfluenzaNet, where the Swedish Health Agency was a part. And so what they did was they called people on the telephone and asking, hey, do you have any symptoms? And then they aggregated that data. And what they could see was that, well, in September every year, we get an outbreak of respiratory infection in Sweden. And I think we all know this, right? You come back from vacation, the kids go to school, and everyone gets sick, right, at the same time. Now, we did an analysis listening to social media and just listening to words like, oh, I'm coughing, I'm having a sore throat. And I think most of you use social media, so you know that people are really expressive about these things. They actually write, hey, I have a sore throat. So if you do that, you will see the exact same thing by just how people talk about it online. And in fact, we did that for a couple of years, so you could see a yearly recurring spike in September of respiratory infection symptoms mentioned in social media in Sweden. So, well, I think this is called, what is it called? But you can do this type of symptom analysis by using social media. I think it's quite interesting. So I'm going to take one last example of this. I think this is quite nice. So here we have the green line is basically positivity, so how happy are people based on what they write in social media in Sweden. And the other curve, brownish, yellowish one, is headache. So when people say that I have a headache, basically. So what you can see here, well, you see some daily patterns, right? So people have headache during the day and not during the night. It's just an effect of that people write during the day and not during the night. But you see that people feel a little bit better on the weekends. You have this positivity increase on the weekends and headache goes down. And then you have Christmas and New Year's. Everyone is really happy. No one has headache. And then on New Year's Day, a spike in headache and a decrease in happiness. So you can see how Sweden feels by using this type of analysis. And some of you have already recognized that this can be framed as a type of sentiment analysis, right? So sentiment analysis is basically trying to analyze how people feel. Are they happy or are they sad? And this can be done in several different ways. We're still in the very simplistic techniques area. So people typically use sentiment lexica. So words that have what is called the prior polarity of sentiment values. So that would be a word like, well, good or bad, great, etc. And there are several huge amount of sentiment lexica available out there that you can try out. And there are also some very nice comparisons of how these sentiment lexica actually perform. So I'm not going to spend any time on this. This is just to show you that there are a couple of tables I have here, and they represent the performance of sentiment lexica on different types of data. So first we have reviews on sites like Amazon, and then we have comment sections, and then we have social networks. And we also have a separation between 3 classes and 2 classes. 3 classes would be positive, negative, neutral, whereas 2 classes would only be positive, negative. So basically what you see is different lexica are good for different things. So if you're going to use this type of simplistic technique, make sure that you have the right lexicon for your domain, right? Or just build one yourself. Now, we're going to leave these simplistic techniques and look at this picture, because it doesn't matter how good you make your list of keywords, they will never perform as good as if you have trained a machine learning classifier to do the job. That's just a simple fact. So the blue columns are a standard sentiment lexicon, and then you can improve those results by using some clever weighting of the sentiment terms. But as soon as you start using just standard supervised machine learning, you will get an increase in performance. And we have a question.
Yes, we have a question from the audience. Stina asks, do you buy data from social media companies or is it entirely open source?
Yeah, so I'm a researcher, so I neither buy nor collect data. I use open data collections, and there are several of those. Like the biggest one is called Common Crawl. It's huge. It's all the data that you will ever need, and it's available online and on instances on Amazon also. But I would say, as a company, if you work in the social media sphere, there are examples of both approaches. So some companies collect their own data, so they have lots of web crawlers, and I mean, you can do that, but it's quite resource intensive. And I know other examples of companies that buy data, because there are companies specializing in just data collection and data selling, and those companies are quite good. If I would have a commercial application where I needed web data, I would simply buy it from someone, because then I would get good quality data. But as a researcher, I tend to just use like Common Crawl or open data. And of course, we're talking about security applications. So actors in the security domain might have data. Right.
So what's kind of the latency of an application like this? Would it be near real time or?
Yeah, so it depends on what you're doing, right? So I mean, if what you're interested in is detecting how people think about new laws in Sweden or something like that, or if people feel unhappy about the current situation, the latency is probably not of concern. You can do batch processing every week or something like that. But on the other hand, if you have a pandemic outbreak that is quite critical, you might want to do analysis at least on like hourly basis, right? So, I mean, Twitter is a good example of where you have near real-time feed, at least. But, I mean, in my experience, I probably have never seen a scenario where latency has been one of the issues. I haven't seen that. But there might be such cases. Yes. So, if at all possible, and if you're going to build stuff in this area, use machine learning. Spend the time to annotate data and use machine learning, because that will give you the most benefits. So the standard approach, and I'm guessing that some of you are very familiar with machine learning, but I'm going to go through it anyway. So first we do the NLP things, segmentation, tokenization, normalization of the data. And then we build something called a bag of words. This is the standard representation of a text. And it simply means we take all the words in the text, put it into a bag and toss it around. So we disregard the structure of the text. It's only the bag of words that the text contains. Or the character n-grams. That's an option. And then we weight these words with some term weighting scheme. The most commonly used one is called TF-IDF, which stands for term frequency times the inverse document frequency for all the words. That's a very old and standard method, but it's surprisingly powerful. And we have a new question.
Yes, Robusto asks, is it easy to identify the native language of people based on the structure of their sentences or use of certain words when writing in English? I guess if it's not their native language.
Yes, okay, so very good question. And let me come back to that, because we're going to talk about that soon when we come to profiling. Author. Very good question. Remind me if I don't come back to it.
Will do.
Very good. So, standard approach. Build your TF-IDF representation, throw it into your favorite machine learning algorithm, Support vector machines tend to work good for language data or logistic regression. Random forests tend to be something that people use in other areas. Typically doesn't work well for language data. And this is also something that I normally would ask the audience, why do you think it doesn't work? And the answer is that random forests, that's an ensemble model that randomly selects some features and try to build small, simple classifiers based on that. If you have a bag of words representation, that means that almost all of your features will be 0. It's a very sparse representation and high dimensional. So that means that almost all the trees in your random forest will have learned from nothing. That's why it doesn't work in language. You have to condense your representation, then it works. Anyway, you would have a choice between using this traditional statistical machine learning and the deep learning approach that we talked about. You have your text, you might do some tokenization, but you don't have to. You can just feed it into your deep learning system. And there are several different architectures for deep learning. If I was here 2 years ago, I would have said that, yeah, convolutional neural networks and recurrent neural networks are what people use. But since the last 2 years, that's not true anymore. Now people only use what's called transformer models, which are based on attention mechanisms, and you stack that layer after layer after layer. It becomes very, very powerful algorithms. But of course, the problem with machine learning, as we talked about in the beginning, is that we need to have training data. And not only we need to have any training, we need to have good training data. Sufficiently many, sufficiently good and representative examples. Otherwise, we're not going to be able to train a machine learning system. And that's such an important point. It can't be expressed clearly enough. You will not be able to produce a machine learning system if you have shitty data. It's as simple as that. You need good data. And then the problem is that producing these training examples is very manually demanding. It's time consuming and resource intensive. And in many cases, you require human experts. So if you're going to do this for warning behaviors, you need highly trained psychologists and domain experts, and their time is costly. Question?
Yeah, so when you say that, how do you even construct this training material? I mean, those psychologists, do they themselves write text that kind of simulate the target?
So typically we wouldn't do that. Typically we would try to find examples of text, and then someone would say, yeah, this is an example of this phenomena. So when we talk about sentiment analysis, for example, then you would download a lot of reviews from wherever, and then you would have someone read all the reviews, and for each review say, yeah, this is positive, this is negative, or this part of the review is positive and this part is negative, etc. So it's very, very time consuming. But that's a very important question, because you need to have data from the right distribution. So if you're going to apply your model then to web forums, it's not okay to produce training data from news articles, because it's a different set of expressions, right? So you need data from your distribution, and you need to annotate that data.
Yeah, I guess like if you're collecting terrorist text, I mean, you might not have that many.
Exactly. So that is also the reason why people use these simplistic approaches, where someone says that, yeah, I think people are talking about, I don't know, radical Islam, sounds like that. But on the other hand, there are some examples of manifestos, for example. There are some well-known examples of manifestos, and several of the school shooters also published different types of manifestos. I would say they're probably too small. It's a too small set of data to use, but it's not necessarily not possible, right?
Yeah, and I guess it would be interesting to see if you take a manifesto and see, is this a someone that will actually act on it,
Yes.
or is it just someone talking?
So I think that's one of the holy grails in radicalization research. How do we actually figure out if this person is going to act on his views or not? Very difficult, I think, since we have so little examples. Yes, but so talking about annotation and how good are humans at actually identifying if something is good or bad in this case. And these are some examples from the literature, and they range from very good, like in the first case we have, and these are correlation scores, so humans correlate with each other 91% of the time, and that's quite high, right? But we also see examples of very low correlation scores. So imagine if humans only agree to 40% of the time, and then you build a machine learning classifier based on that data, then the upper bound for that machine learning system is 40%, right? Is that useful in a practical application? So this is a good example, and when it comes to hate speech, we have even more diverse inter-annotator agreement results, as it's called, ranging from all the way up from 90 plus, all the way down to like 18% agreement. So this shows you that these type of categories can be quite subjective and not necessarily easy for even humans to analyze. So you can't really expect the system to learn to recognize this if humans can't, right? But this is where we can leverage what's called transfer learning. So basically what we would do here is we would use a language AI system to learn an embedding of language, which is something that we saw earlier, right? The topological structure of words. So basically we can use a language AI system and expose it to like the entire Wikipedia or the entire Common Crawl or some really large data set, and then it will learn general language. And once it has learned general language, we had some issues with sound or image, but I think we're back. Great. So I don't really know when I was lost, but I'm going to repeat the transfer learning idea. So you have a language AI system that learns a general representation of language by simply reading large amounts of text. And the benefit of doing that is that you can then use this language representation to learn specific applications. And the benefit of doing that is that you will require less amounts of annotated training data to solve the problem. So transfer learning is a very powerful technique to use when you have small amounts of training data. And this is also what I would say the kind of approaches that we are working on right now in basically all types of applications of natural language processing. Right, so, I'm talking way too slow, but I'm going to talk about profiling, and now we're coming to the question that I'm going to remember to talk about.
Do you remember the question? Or do you want
I remember the question, and I'm going to try to squeeze it in here. But so profiling is the application where we want to try to say something about an author of a text. So imagine that we get a hate letter sent to us. Can we figure out who sent it by just analyzing the language? That's the question. So it's also called author identification, so identifying the author in question.
Yeah, I have a question from Lars. Was the agreement in percentage or a correlation?
I think these are kappa values. So correlation, yes, I think so. These are taken from the literature, so I'm gonna hedge and say that I hope it's in kappa, but it's not necessarily true. It might be a blend. Well, I don't know. Yes. So author identification. So that's also the task of trying to infer some features of the user, like the gender or the age or the origin. And here comes the question then. Can we, depending on how a person writes in English, determine the origin of that person? And I know that there are companies who are actually doing this. I'm not sure if they are actually doing it based on machine learning or on manual analysis, but I would be surprised if the accuracy is very high for a machine learning classifier. I think in certain cases you might be able to do that if you have very clear terminology, for example, or slang words that are used only in a geographic area. But in general, I think it's hard to detect the origin on text. Much easier on spoken language, of course. But I'm primarily working with text data, so yes, that would be hard. But there have also been some work on trying to detect education levels based on how complex language people use, or the political position of people, and even sexual orientation have people looked at. So, and in general, I would say that these type of techniques work in the broad spectrum, so you can see general tendencies, but in individual cases it will be much more difficult to say something, and you need fairly large amounts of data to be able to say something about an author. Okay, but we can take the example of trying to detect who is the author. So if we have candidates, it will be a supervised problem, so we can apply machine learning. If we don't have candidates, it will be something else called profiling. Did we have a question?
No.
No, good. So imagine we don't have any candidate authors. We only have some different texts. Now, if we have representative data of, for example, an age group, then again it's a supervised problem and we should use machine learning. But if there is no known data, if we only have texts of prospective authors, then it's a question of stylometry. And this is a quite old idea in natural language processing, where we try to separate different types of authors based on the style of their writing. And then you would look basically at like how much stop words do they use? How much commas do people use? And do they use the word however a lot? And things like that, stylistic variables. I'm not going to talk about this because I'm so slow. Question?
I have a question. Perhaps you can repeat the question as well? So
yes, very good, yes. Yeah.
So, as a question for me, do you know how is this used in like the police force or like in crime to narrow down suspects? And
so yes, yes. It is, and there are a couple of cases where this type of analysis has been used in court. Not so much in Sweden. It's used. I wouldn't say often, but it has been used in court in England and in the US, and there has been cases in Sweden also. But this type of analysis would never be the most important type of evidence. It would be a corroborative evidence, so an indication. Right, because this is scientifically not very precise type of analysis. It will give you an indication, but nothing more. But so you can do some interesting analysis, and for some reason people always use the works of Shakespeare as an example. So basically what you see on this graph is that you have some known works of Shakespeare, and then you have some works where the author is not really known, but you have some candidates, so in this case Fletcher. And then you can look at the style of writing in these different works, and you will see that the stylistic profiles will be different in different parts of the work, which might indicate that someone else wrote one of the works, for example. But as I said, this is quite imprecise, but still it can give some general tendencies on the data. And again, lots of tables, don't mind the exact numbers here. I just wanted to show there is one column that is labeled accuracy, and if you just look at the figures there, you will see how good these techniques are on very controlled test data sets. And you see that in some cases you can actually get fairly good accuracies on author identification. So it can be used, at least in very controlled environments. These are also just accuracy measures and some different types of features that people use. And again, you can get up to over 90% accuracies using standard statistical machine learning approaches. Nowadays, I think most people would use deep learning for this. So these type of systems that we talked about. And this is quite an interesting, I think, table. This shows authorship attribution evaluation results in different languages. And for some reason, it seems that some languages are more difficult to identify authors in, like Polish, for example, here. So again, I think most of these are quite simplistic techniques, and it would probably be able to perform a little bit better using deep learning systems. Now, an interesting application here. So imagine that we use this type of technique to identify authors. We might as well reverse these techniques to obfuscate who we are when we write. So we can do that. So imagine that I'm an adversarial actor and I want to write some really nasty comments online. Then I can feed my text into an author obfuscation problem, which will remove all my personal identification stylometric features from the text and just produce a text that is not as I write it, but still has the general sentiment, right? And then comes the question, so could we also think of countermeasures to people who are actually using author obfuscation measures, right? And this becomes a very interesting cycle. And we previously talked about hackathons, and this would be a really cool set of hackathon ideas, I think. Okay, I'm going to end with talking about information operations, and I'm going to be over time. I hope that's not a problem. Okay, so information operations is quite related to OSINT, but here we don't only want to measure what people think, we want to actually influence what they think and affect public opinion. There has been some very published events in this sphere, like Cambridge Analytica on Facebook, and you have the Internet Research Agency in St. Petersburg, which was basically a troll factory. And you have all these other terms that are related to this, like trolling or polarization. But the general idea here is that we want to, in a sense, generate language and just push it out into any domain to try to make people be influenced by that. But of course, we have the question, so if we want to influence people, how can we know if we succeed? How do we actually measure if we have influenced people? And this is where people usually say, well, we can use sentiment analysis. And I would say, no, you can't. That's too crude. And we have a project on this that I'm just going to mention it. It's called Linguistic Explorations of Societies. And the idea is to try to use open web data as a complement to traditional opinion polls. So when social scientists try to figure out who is going to win the election, what they do is they interview people, right? Opinion polling. The problem is nowadays people don't respond to opinion polling. It's really difficult to get the data. So we're looking into, can we actually just listen to social media and figure out what they think? And it's not enough to do sentiment analysis. We need to figure out what they actually think. Right? And the way that we do it is measuring how people use concepts. So when people talk about democracy, for example, what does it mean? What do they mean by democracy? Or corruption, what do they mean by corruption? And once we have figured that out, we can maybe measure whose language use actually drives opinion. Right? This is called issue ownership or agenda setting in social science theories. So what we have done is, I'm not going to talk about this, I think. We have done a very simple system that collects web data, or actually we buy it in the research project from a third party, a vendor. They sell social media data from several different countries, and you can actually split the data into news data and social data. And we also have language identified all the data. So we can split based on source type, language type, and region. And that makes it possible for us to compare language use across the world. And in this example that you see, we have the term democracy in German media, news media, versus the term democracy in Russian news media. And you have a column here that is labeled translated term. And if you look at that, you can really see the difference in how democracy is being used in these different countries. And this gives you an idea of how these concepts are used. And then you can use that type of underlying representation to measure the influence of media on different media types, or the influence of media types in different discussions and the influence of political parties on different media types. And this table here is quite difficult maybe to make sense of, but basically what it says is that if you have nativist media that talks about nationalistic values, and you have a distinction between different types of political issues, so traditional left-wing issues, traditional right-wing issues, etc. And then you have the political party manifestos. You can actually measure how close are nativist media in right-wing issues to the political parties. And what you see in this graph basically is that, well, nativist media tends to lie closest to one of the political parties in Sweden. Not surprising, but we can do this type of analysis. And we have a question.
Yes, we have a question from Hans. Can we use machine learning to decide if a text is written by a person or generated by machine learning?
And that brings us to text generation. That's the perfect question. And this is what I'm going to end with now. So these deep learning systems that we use now, especially in transfer learning, are extremely powerful, and basically we train them to generate language. This is the training objective of these systems. So they read lots and lots of language, and the task that we train them on is to predict the next word in the sequence, or some variation of that. And that means that these models, if trained correctly, will be very good at generating language. And in particular, we have a model called GPT-2, which was trained on very large amounts of web data, and that sparked a lot of debate in the field, and I'm probably sure that some of the audience have heard about this. It's a huge model, 1.5 billion parameters. It's based on a transformer architecture. And it was built by an American company called OpenAI, and common practice in my field is that you build your models, you also publish the model, because other people might want to use it and enhance it and improve on it, etc. But, and quite funny actually, OpenAI took the decision to not be open. They actually didn't publish this model. And they didn't publish it because they were concerned of how it would be used for adversarial purposes, because it was so good at generating language. And these are just a couple of quotes from the blog post that they published, and you have the link there also if you're interested. So that sparked a whole debate on how do we do with these models. They're so powerful, what can we do? And of course this model is now published and people have reproduced it and built their own models. But the fact is that these models are very good at producing language. And in fact, we have models that are built only to detect text generated by these models. So the picture that you see here is the family of all these different types of model, and GPT-2 is on the right up there, and then you have you see there is an arrow called defense to a model called Grover. The Grover model was built specifically to detect text generated by GPT-2. But of course Grover is even better at generating text, so you have this cycle, right? But I would say that this is probably where we are going to see the most adversarial use of NLP going forward, is text generation and use of text generation techniques for information operations. So I recently heard a computer security expert who basically said that, well, computer security it's not a solved problem, but we have very good tools for that. The next big challenge in computer security will be social engineering by information operation techniques like text generation. And I also think this is challenging, interesting, and we are going to focus a lot of this in the future. Okay, so then next slide, I think this is just to show you how powerful these models are and the number of parameters that people nowadays use to build these models. You see the second to the left point is actually GPT-2 1 from OpenAI, and then you have OpenAI GPT-2 somewhere in the middle, 1.5 billion parameters, and that was in January 2019. And we all thought that was so many parameters, never going to use any more than that. And then in January, just this year, we had a model from, I think it was from Microsoft, it's called TNLG, which had, I don't even see, like 17 billion parameters, right? And this requires enormous amounts of compute. And that is also like a democratization problem, because only big actors will be able to train this size of models, right? And so they have these powerful models that can detect and generate language, but what do small actors do in this case? So yeah, interesting, and hardware requirements and also data requirements. Yes, one question.
Have you seen these as like a business model for social media companies like Facebook and such to build and train models?
So yes, Facebook is you see the logo there. They're quite active in this area. They have Facebook Research, AI Research Fair. They contribute a lot to open source code in this area, but of course they have access to large amounts of data, and we probably don't see all the models that they build, right? I think it's a huge problem for us in Europe, because these models and all the data is driven by American companies, and I think this should be of concern for us in Sweden and for Europe, because it's a question of power, I think. Right. The last slide. I'm just going to stop here because we are in the middle of basically a breakthrough in language AI. This is just an example of tasks where computers have beaten humans, and chess was way back, but just in the recent years we have seen near or even exceeding human performance in a number of tasks like computer vision. Go was a big thing just the other year, poker also, and just the last year now we have seen language tasks also performing on a par with humans. And these are these very powerful techniques that we've been talking about. So we are really in the middle of a very interesting breakthrough. So I think we're going to see more use of NLP in these type of applications. And that's all from me. Thank you.
I have a question. So people usually say one thing in public or write something, while in private they express something different. Would it be possible to kind of see through these lies with NLP?
So that's a very interesting question, I think. So I think you would be able to detect idiomatic expressions, which are very common in a domain. So I think it would be a very cool experiment to see which are the common phrases politicians use, for example, and how do they differ across parties. And I think that type of language use might be an indication that you're only following the party line, or you're following the general discourse. You're not really expressing your own thoughts. But I mean, also, if you could track a specific person and analyze that person's language use over time, you would definitely see some interesting temporal relations and progress. But I would be quite hesitant to start tracking individual people online. I would not be comfortable doing this. Yeah.
Good. We have another question here from Hans. Most of the machine learning models and data sets are in English. How big models do we have in other languages, such as Swedish?
Yes, very, very good question. So, and that's also related to the democratization issue that I mentioned. So most of this work is done in English, and partly because of the actors are English, of course, but also because English is a structurally very simple language. It's very easy to do analysis in English. There is a very spare morphology, for example. So compare English to Finnish, where in Finnish you have very complex grammatical relations. There are some examples of multilingual models that have been trained on like Common Crawl or several different Wikipedias, and these models will have learned several different languages. And then you can take advantage of what we talked about, transfer learning effects. So a model that has been trained on Swedish, Norwegian, and Danish will have benefited from all of these different languages. But I would say also that we are working quite hard in Sweden right now to build these type of models for Sweden. And we have several different projects at RISE where we build these type of techniques for the Swedish public sector that will be open and accessible by government agencies, for example. So I think that's very important, and I think that's important for us in Sweden, and it's important for Europe to try to catch up, basically.
I once heard that there are like different resolutions of different languages. So Russia, for instance, being like a high definition language, while English being a bit more simplistic.
So as a linguist,
would you agree?
I don't really know what that means. but so
I would say that they have more words for, like the people in Greenland have like lots of words for snow, for instance.
So that's a well-known linguistic myth. So all language can express everything. All languages have basically the same expressivity, right? The vocabulary is different, of course. I mean, of course, we will have more concrete words for snow than Spain, for example. I'm guessing, I don't really know. But you can express skare, for example, in Spanish, of course. It's snow with a hard surface or something like that, right? But there are interesting typological differences between languages. So as I said, like English doesn't have basically any grammar. It encodes grammatical relations by word order. Whereas in Czech, for example, you have not really free word order, but you have very complex morphology instead, right? So you have these interesting effects, and that means that you might have to train your models in a different way. And if we only develop models that work for English, we're not going to be able to apply them, perhaps, to other languages.
Yeah, we have one more question here, or two actually. So, in how many years, so this is another question from Robusto. In how many years will kids use machine learning instead of writing their own school papers? In my days, we used to just do copy-paste.
Yeah, good question. So I think that depends on the parents, if they have installed the GPT-2 engine on the kid's computer, they can probably do it today, right?
There are like software on high schools now,
Yeah.
or universities, where you kind
Yes.
of see if they have taken parts from different.
Of course, and those systems are quite powerful, and I think they work in many cases. But so what they do is they look for copy paste basically. They don't look for generated content because that doesn't happen yet. But it will happen soon, I think. There are examples of people actually auto-generating complete scientific papers and actually getting them published, which is quite interesting. But so we're going to need to come up with countermeasures with this. Yes.
I got one more question here from Lars. Has NLP been used for applied on computer language, like to find out where a piece of malware originates from, for instance?
So I don't dare to answer that question in a precise way, but I think that these general transformer architectures have been applied to lots of different types of data, like code, for example. And I think they have actually built like code prediction systems based on this. So trying to predict what is the next statement in a piece of code. And I'm guessing that you could do it for malware also. I'm not an expert in that, so I couldn't say.
Okay, great. Thank you very much, Magnus. Very interesting talk.
Thank you very much. Oj, vad snällt. Tack så mycket.
Tack.
Tack.